So today we'll see about searching and insertion in a BTree. Here this is an example where we have already seen it in the previous class, the example of inserting into a BTree and how does it work. Okay, here in this we are just going to see how does searching works. Okay, the first problem which we have to going to see is how do we search L. Okay, now here first thing which we have to see is first itself we load the root into the memory, then we'll search each and every key of the node with the key to be searched. Okay, so first itself we'll come into the root node, we'll search P. Okay, we'll search with P whether it is less than or equal to. So the condition is whether L is less than P or whether L is greater than P. Now the condition which comes true is L is less than P. So in that case what we have to do means we have to move to the next node, that is the left side node of P. Okay, for that what happens, we have to read the reference address of this particular node, that is this one. Okay, so this address is loaded and now it go for the second node. Okay, and after here now the next condition which we have to check is we'll check with D whether L is less than D. No, L is greater than D. So we go for the next. Now with M we'll check whether L is less than M. Yes, in that case we go for checking for the second address, that is the address which locates to the leaf node, the second level node GIM. Okay, so now once this has been loaded, we'll go for the third second level node, that is GIM. Now we'll go for searching whether L is there inside our node or not. Now we'll come to a conclusion that L is not existing. In that case it returns -1 value, telling that it is not found. Okay, now in the case of G, when we consider G, the same conditions have been checked. We check with P, it is less than, so we go with D. No, it is not less than, it is greater than D. So we check with M, yes, it is less than M, so we go for the second root, that is GIM. Now there when we check, we finds G. Now what happens, the location of G is been returned, telling it is found. Okay, this is the two case which we are going to see with the algorithm. Okay, so this is how the algorithm works. The search algorithm is having mainly two methods to be executed. The first one is search. Okay, and inside search you see that we are having leaf node. Okay, it is an node type, and then we are having the method find leaf. This find leaf method helps us to iterate throughout the tree from the root till the node for searching whether a particular key is existing or not. So okay, and once it searches the whole branch, it returns you a value telling whether it is existing or not. In our L it returns you -1 value, and in the case of G it returns you value 1, or the position of where that particular key is existing in which level. Okay, so here you can see leaf node returns a value, and then you can see that it also calls search method once again. Okay, of the key and the record address. So here now the search is understandable. Now we see what is happening inside findF. So in findF we see that the type, the parameter is again key, and here we are having a for loop which starts from level 1. Level 1 in the sense it starts from the root. Okay, and here the condition is record address is equal to node of level 1 and search key. Okay, now what happens here is you are having the condition whether L, that is the key, is less than or equal to the first node, that is in the previous case it is P. Okay, so that is what in the case of level 1 it will be P, and in the case of level 2 it will be D. We have already seen. And once if it is less than, what have to be done, we will select the next level node and we'll try to load it into the memory. So that is done in the second code, that is node of 1 is equal to fetch of record address. The address whichever is returned in the previous is being loaded, and that particular node, that is the next second level node, is loaded, so that once you increment the level for in the next loop, we can go for searching whether the L is existing in the particular node or not. So it returns, if it is found, it returns you that location, else it returns you -1 value. Okay, so this once again I'll just explain here. So we are having the search telling that L have to be searched, and then we check with find leaf. Okay, in find leaf method, what it does means it keeps checking throughout the particular branch, okay, where it is found or not. Okay, so it starts with root 0, that is the level 1, the root node, and here the record address node 1. This is the condition where we have to check whether node P means the first node, that is P, is less than L. Okay, so that is what we check here. If it is less than, we go for the next one. What happens? The record address of P, this one is returned in record address. Now it is given to the next one. What happens? It loads the second node inside your node level. Okay, now what we have to do is, once it is loaded, now we again have to search. So we come to the loop and we check whether D is less than L. Okay, no, it is greater. In that case, we go for again checking the second condition, M. If it is less than, we load this address, so that now this node has been loaded, and there we go for, by using this, it has been loaded, and we'll check whether L is existing or not. Okay, so this is what happens, and in the same thing happens here also, as I've already explained. Okay, and second case is in the case of G. The same procedure happens. Now once G is found, that particular location, that is this location, is returned. Okay, so when if it is not found, -1, if it is located, that position or the address has been returned. Okay, now when we go for the case of insertion, in the insertion we have mainly 3 phases, okay, or 3 main steps. First one is we have to search throughout the level whether L is existing or not. Okay, and or where do I have to insert this particular key. Okay, after we found a position, it is found by using find leaf again, and then we go for inserting it. When you do the insertion, it happens that sometimes your node ends up with overflow. If overflow is detected, in that case we have to split the nodes, and the splitting keeps moving from down till up to the higher level. Okay, and when the splitting is done, we have to do the creation of new nodes and insert the key.